Hi guys, hope today finds you well. I talked to you about just walking you through the rest of this problem. So my goal is to do that with you guys here just to make sure that we can get this good approximation all the way through. We basically just have to work through this summation. So I'm going to help you guys do that. So just some quick reminders. We found the width of the rectangles by taking the length of the interval dividing by how many rectangles there are. We had to find x sub I to plug in, so we could find f of x sub I, which is the height of the rectangles. We noticed that it had to be 2 plus the width of the rectangle, so 2 plus I, 1 over 50 times I. And we plug that in. The sum from I equals 1 to 100 would be the right side. 1/50th times f of 2 plus 1/50th I. I took the 1/50th out. Okay. I also then put this into our function f. I evaluated f at 2 plus 1/50th I. Okay, and this is where I'm at. So I'm just going to work through the rest of this so that you guys have it, because we've only done working through a sum like this once so far. Okay, so 1/50th times the sum from I equals 1 to 100. Now this is cubed. I'm going to have to cube this out. I've got my book over here. I'm going to look up my pattern for cubing a binomial to save myself some time of actually having to FOIL this out twice. Alright, here it is. So I've looking in the back of my book, I found the pattern for x plus a cubed. It's x cubed, which is 8, plus 3ax squared. 3ax squared. 3ax squared. I think I'm just going to come back instead of trying to do that one step. I'll come back and figure out what that is. Plus 3a squared x plus a cubed. And then we've got that plus 1. Okay. Depending on where you look up this rule, it might sound a little bit different. This is my x, that was my a. Cube it out, that's what I get. Let's simplify this now. (1/50th) times the sum from I equals 1 to 100 of 8 plus, okay, I have 2 squared, which is 4. I have 12/50ths, right? 4 times 3 is 12 over 50th. 12 over 50 would be 6/25ths I. Plus, let's see here, I'd have a 6th. I would have 1/50th squared, so that's 6 over 2500 from that 50 squared, and the I is squared, plus 1 over 50 cubed. 1/50th cubed would be 125 with what, 3 zeros? I cubed plus 1. You know what? I'm going to take that plus 1. I'm going to put it with my 8 up here. Make that a 9. Now, we have seen that when we have a sum like this, we can take the sum of each part individually. Now, with each of those individual parts, like this 6/25ths I, we can factor out a 6/25ths. Here we can factor out our 6/2500ths, and here we can factor out our 125 thousandths out. So what I'm going to do is I'm going to say this is the sum from I equals 1 to 100 of 9 plus 6/25ths times the sum from I equals 1 to 100 of I plus 6 2,500ths, the sum from I equals 1 to 100 of I squared. One more to go. And that's going to be in I cubed. Now the reason I did this again, because we have formulas for these sums. Sum from 1 to 100 of 9, that's our constant. Remember, we can just take our constant times our upper bound n. That's going to give us a 900. Here we have 6/25ths. Sum from I equals 1 to 100 of I. Okay, our rule for that is n times n plus 1 divided by 2. And that's 5,050. We've done that one before. 6 over 2,500. Sum from 1 to 100 of I squared. Just double checking my formula. I squared is n. I wrote this one down wrong, didn't I? That's 100 times 101. Alright, we've got n plus 1, 2n plus 1 over 6. And last one, I cubed, is n squared. That's 100 times 100 times n plus 1 squared. I'm just going to write that as 101 squared for now, over 4. Oofda. Alright, I'm going to see if there's anything I can cancel out here before I really plug this in. I noticed the 25 and the 100 is going to reduce that to a 4. This 2 is going to reduce the 6 to a 3. 6 is cancel. I'm going to reduce this by a 100. I'm going to reduce this by 1,000. I'm going to reduce the 4 and the 10 and the 4 to a 2 and a 5. Looks good. I'm just going to pause the video quickly as I grab my calculator and type this in. Pretty long string there, but I got about 62.56 for the area under the curve there. Does that seem reasonable? Let's think about this a little bit. Okay, look at our region. We're going from 2 to 4 on x cubed plus 1. If I plug in 2 cubed plus 1, that's a height of 9, isn't it? Let's see, that's 9. 4 cubed plus 1 is 65. Would you agree that this roughly, kind of missed on that one, is the shape of a trapezoid? So if I take 1/2 the height times the sum of the bases, look at that, I get 74. Okay. Does it make sense that our approximation would be less than 74? I think so. I think we got a number here that seems pretty good. Okay. Now, to finish this up, we did start to set up that left side yesterday, where we got to have the sum from 0 to 99. So we talked about, well, we know from 1 to 100 we have to add on that first one when I equals 0, and we have to subtract off that last one when I equals 100. So we've got 1/50th times f of 2. Now f of 2, I just did that. That was 9, wasn't it? Plus, this is the sum that we already did. That's the right. That was about 62.56. Now we have to subtract off 1/50th of f of 4. F of 4, the height there was 65. Here we go. 1/50th times 9 plus 62.56 minus 1/50th times 65 gives me about, good morning, 61.44. So hopefully that was helpful walking you guys through the rest of that problem from yesterday. Good luck, work hard, help each other out on today's practice.